Today we will take a look at how to create a window using the Win32 API, because I think it's still worth to understand how Windows is actually working under the hood. Even though I'm well aware that nowadays we have all these kind of nice abstractions. For example, if you create a Windows application using .NET Framework with XAML support and UWP, then basically everything is made very easy for you. You just have event handlers, and the UI you can also draw yourself, or you can describe it in XAML files and text form, and then this is somehow loaded for you onto the screen. And I'm also well aware that nowadays in Windows there is the Win32 API, which gives you a sandbox and a new API style of accessing the operating system functionalities. But even then, because the desktop remains relevant still, it is good to also have an understanding how this actually works under the hood. And this is why today we will take a look at how to create a window using really low-level functionality of the Win32 API to do so. And that way we will also broaden our understanding of how Windows works behind the scenes. In order to get us started, I've created a small project setup based on CMake. That is actually rather simple. We can have a quick look at that file, but it's not relevant for the discussion of this tutorial. Basically what we do here is we create a new project called Polychrome. My intention is to extend this application later on to a full-blown 3D game engine. I think Polychrome is a nice name to do that. But in the end we just link in a main CPP file here, and then we give some options to compile in C++23 mode, and we supply some macros so that the compiler automatically creates a Unicode application for us instead of an ANSI, which is outdated. And then we give some compiler options so that we also get all kind of warnings turned into errors. And that's basically it. Then we can already take a look at our main CPP file. I've already created some code for us to make this all easier. Actually, this is the second recording of me doing this, but the first one I forgot the screen recording, so you can see me writing the code and then also get a little bit frustrated because the last time I did these kind of things is also a little bit in the past, so I was not fully knowledgeable in all the function calls, but now we are all set. Actually, in the first recording we got quite close already, but I think this is now easier to explain as we have the code already at hand. So what we want to do in the first place is, in order to access the Win32 API, we include Windows.h as a header file. But I also decided to put this Win32 lean and mean macro definition in front, so that we include less. Otherwise we include a lot, which puts some burden on our compilation process. There are even more macros that you can define to include less and less and less of the Win32 API. I think if you look at this Windows, see at the beginning of this file it already gives an indication of all kind of macros that you can define, and that will exclude certain parts of the Windows API that you are probably anyway not using. So this list might be handy as well to define, depending on your particular setup. And then we have two functions in here. We have a window procedure, WNDProc. We will take a look at this later, and we have the WinMain function. But notice in the beginning I said we are compiling a Unicode application. Windows at some point in time made the step from ANSI to Unicode. And then many functions that do string handling existed in two versions, one with a W extension and the other with an A extension. But in order to make the code compile or to have some kind of migration strategy in there, they also introduced a T version of every function or of every type definition that deals with string handling, so that you could decide at compile time if you want to compile an ANSI or in Unicode. But by default in this setup we will use the Unicode versions. This is why we had those macro definitions in the CMake lists also in the first place. So you will see functions which somehow have a W attached. So in this example for the WinMain, you can search the Windows documentation also for WinMain, then you will find references. But here we use the Unicode version. And similarly, for string types, in this example, we use W. If you see this without the W, or if you see this with a T, then you know where this is coming from, but we base everything on the Unicode version. Also, for example, in this WNDCLASSEX W, you find the W again, so don't be confused about that part. You know now where this is coming from. If we want to write a Windows application, what we typically do is we start with WinMain instead of the normal main that we know from C or C++, and then we get access to some of the parameters that the operating system passes to us that is basically hidden from us when we use the C or C++ main version. And the C and C++ we have the args and the argc. Basically this we also get with this parameter, the command line, but then before our main is called, the operating system already splits this command line into these individual args. So here we get the full version. Then we also get an instance, which is basically a handle of the operating system to our application of our application. And then this pref instance is a relic from the past. We don't use that anymore. And this show cmd is an indication from the operating system if our application starts a window, which we want to do eventually. Shall we show it by default or shall we hide it by default? That we will also use later on. And then the steps to create a window are basically twofold. The first step is you need to register what is called a window class, and then you can only create your window. The way to look at it is Windows is based on Windows, as the name already suggests, but many items on the screen are actually a window of its own. So for example, a button is considered a window, or a checkbox is considered a window. And Windows, behind the scenes, groups windows into classes. So all buttons are a class, all checkboxes are a class, all radio buttons are a class, with their own behaviors, with their own properties, with their own drawing style, whatever. And the same we also want to do. So for our application, before we can even create the window, we want to say, this is how our class looks like. And the way to do it is to create an object of this window class or WindowClassEx struct, and then fill it with some data. And this way we describe our class, and then from that class we could instantiate different windows, multiple windows. But in our case, because we only want to show one window, basically we create one class, and then from this class we only create one instance. But potentially we could create multiple instances of that particular class. So imagine we want to have our own kind of checkbox, and then we could create the window class which implements our checkbox, and then we create main checkboxes from that class, displaying it on our application. In Windows, what you will see is you will find naming conventions like these X, where already a type like window class existed in the past, and then over some iterations of the API the class was extended. This is where this X comes from. And then typically it has the members of the old class, but also the members that have been added. And in order to support that properly, many of the structures in the Windows API, they have a size member where you can give the size of the actual data structure. And then Windows can know if there are additional items or not in comparison to the previous or the earliest APIs. In our case, we use the X version. You could also fall back to the non-X version, then you have access to less items. I think this is the only one that has been added, essentially. So let's take a look at what we're doing here. We need to give a style. In this case, you can look up the list of styles that are available. I choose for this class style own device context, because later on I want to turn this application into a small 3D graphics engine. And then if we say own DC, basically every window gets its own device context, so we can do our own drawing separate from other device contexts. Then the core of a window class is this window procedure. And this is the function that we defined on top. We will take a look at this later. But the way you want to look at this is every class supports its own logic, and Windows is a message-based system. So eventually we want to start receiving messages from the operating system, which you could translate into nowadays terminology as events. And those messages we handle in the window procedure. And as you can already guess from the way this is set up, every class has the window procedure. So all the windows that you create from a particular class, they process messages in the same way because they refer to the same window procedure. Then you have this class extra and window extra. This is additional memory that the Windows will allocate for you if you create a class or if you create a window from that class. The class extra you can look at, for example, in C++ when you have classes, you can also have static members in the class, so they distribute to all objects. And this is exactly what's happening here. So you reserve some memory and then all windows of that particular class can have access to that memory. While the window extra is like memory that is extra per window. So every time you create a window, Windows will allocate that additional amount of memory, and then you can use that, for example, to store data that is specific to a specific window. Then we also want to give a reference to our application instance, and then we could also define an icon, a cursor, a background, and a menu, but in our scenario we will not make use of that. And then this one is really needed, the class name, because if we want to create a window later on, we need to somehow say to Windows, this is the class we are using, so we define the class name as well. And then the icon, we also don't make use of that part. Then some local variable definitions, because in the code that is following, we will see that we actually use C-style error handling. You will notice that I use some constructs from C++, like for example, the dot notation is available in newer C++ versions, but also the auto, right? That is not C code that we write here, it is C++ code. But because we only call base level C functions, I thought it would also be a nice exercise to show how error handling in C can be done. And because that is based on goto statements, we define all our variables up front to make sure that they are all properly initialized, basically, because the goto could skip initialization. And then we register our class, and in case the Windows API returns an error, basically by saying that there's an invalid atom returned and not a valid atom, then we store the last error message and we go to the end where we just return, as you can see. Otherwise, if we proceed, then we try to create from that class also a window, and this function also has several APIs. There is a CreateWindow and there's a CreateWindowEx, so we use the X to get the latest functionality. Basically that gives us those additional arguments, and then we can use the different window styles. So this basically says, how does my window look like initially? What kind of borders does it have? In our scenario, we want to create a window that is for a main application, like a top level window, and this is where we use those particular styles. Then we also say in the CreateWindowEx what kind of class we are referring to. You will find in other tutorials that here they just repeat like this class name, the polychrome class. But what you can also do is you can cast this atom that you got from RegisterClassEx using this make int atom, and then this will also refer to the correct class. And then you need to give a title for your window, and you can give some parameters about the size and the position on the screen. And there you can also provide like a menu or a parent window, but that is not applicable in our case. You also want to give the application instance, and then you can also pass parameters that you could use during your creation, but that we will also not use for now. And then again, we do some error checking. If we got a valid window, we proceed. If we didn't, then we want to clean up properly. So because so far we registered the class, in the case of an error, we unregister the class. And if we pass that point, then we can show the window on the screen. And for that, we also use the show indication that was passed to us via the WinMain. This function also has a return value, but it basically just returns the previous state of the window, which at this point in time doesn't make much sense because it was not shown previously, so we don't need to take a look at this value. Notice that even though we show the window here, without entering this loop, we would immediately terminate our application. Once we have the window on screen, we want to continue the application until someone clicks on the cross in the upper right and terminates the application. And in order to do that, we need to enter something which is called a message loop. And there are different strategies of how you can implement a message loop. Basically, if you design a standard Windows UI application, then you want to rely your message loop on a function called GetMessage, because the GetMessage function is a blocking function. So you can think of an Excel or a Word application. Those applications, they are not doing anything unless the user does something like typing something or clicking on a button. But because here we want to develop a game engine, you can imagine that the engine still wants to execute game logic, like proceeding with the game state, even though the user is not doing anything. And this is why we base our message loop now on a function called PeekMessage. And that function you can use to check if there has been a message sent to your application or not. If there is a message, you can get the message from the queue. If there is no message, then you just proceed and you don't do anything. So what we say in here is, while our application is running, we want to inspect the queue. If there is a message, we want to remove it. This is why we pass the PM remove. We could also say we just take a look at if there's a message and then we don't remove it, but we want to process it. So we remove it. And then we have to call two functions. One is called TranslateMessage and one is called DispatchMessage. The TranslateMessage is basically used to turn a single message into more messages. It is not so relevant at that point in time. But the DispatchMessage is the interesting part, because this is the part where Windows will execute the window procedure that we passed in initially when I said basically this is event handling. So we receive the message, we call DispatchMessage, and then Windows will invoke this window procedure for us. And then something strange happens in here, because we could just say we just dispatch the message and we handle all the messages in the window procedure. But when there is a specific message, namely the quit message, then we actually want to exit our application, and we do that by then setting this runs flag to false, and then also getting this exit code, which I will explain in a little bit. And then we just destroy our window and we unregister our class, so we nicely clean up everything, and then we just return. So now let's take a look at the window procedure, which is handling the messages for us. And the typical structure of this window procedure will be a big switch statement where you check on the individual messages coming in and handle them differently. So for example, when we receive the close message, which is basically the user clicking on the cross, then we want to send another message to ourselves, which is called the quit message. And for that we use this post quit message, and we can give an exit code. And that is exactly the exit code that we also receive on the receiving side in here in the W param. Because for every message there can be parameters attached, which will be provided to the window procedure using the W param or the L param parameters. So for example, if I click somewhere on my application, I also want to know the XY coordinates where the click happened. And this is something I can extract from those parameters. And of course you can imagine there are many more different messages which have different parameters. And then for every message you want to take a look at the Win32 API. What are the parameters provided and how can I access them? Because sometimes there is some coding or some casting going on in order to really get the data out of those two parameters. Similarly, for every message, this window procedure also returns an L result, and that can be different. In most of the cases it's 0. This is why it makes sense here to just define it to 0 and then don't touch it at all. But in some cases you want to return a different value. And in particular, if you don't handle the message, you want to return the default implementation for that message that is also a Win32 API call. And that's basically it. So if we now start our application, we should just see the window on screen. Here we go. And if we click the close, then the application is stopped. I will also put this code on GitHub, and I will put the link to the GitHub repository beneath that video, so then you can also inspect the code yourself. Happy coding, guys!